So, last class I was discussing how to calculate the tip resistance and the friction resistance for pile in sand considering critical depth concept, and I determine the tip resistance. Now, today I will discuss the friction resistance first, then I will discuss the other topics. Now, first in the next part we have to calculate the friction resistance, okay? Because we have determined the tip resistance for this particular details. We have a critical length of or depth of 6 meter and the tip resistance is 634 kilonewton. Now, the friction resistance I am calculating for 3 different parts. One is from 0 to 1.5, another is 1.5 to 6, another is 6 to 20. So, for the FS1, so for FS1 this is 0 to 1.5 meter. So, that is equal to, as I have discussed, that we have to take the average effective overburden pressure. So, this is a triangle where it starts from 0 to certain value. So, the average value will be 0 plus 28.5. So, that is equal to into K, and K value is equal to 2 into tan delta, into tan delta is 30 degree. So, this is 16.5 kilonewton per meter square. Similarly, FS1 1.5 to 6 meter. So, this is, it has two values. So, half, one is 28.5, another is 69 into 2 into tan 30 degree, that is equal to 56.3 kilonewton per meter square. The next one FS, this FS2, FS3, which is 6 to 20 meter. So, that is now it is uniform. So, 69 into 2 into tan 30 degree. So, that is equal to 80 kilonewton per meter square. So, total friction resistance, that is equal to pi d, and for first part it is 16.5, length is 1.5, second part 56.3, length is 4.5, and third part is 80, length is 14. Okay. So, this is equal to 1317 kilonewton. Okay. So, this is kilonewton. So, Q ultimate is Q PU plus QF. So, this is QPU 634 plus 1317. So, this is equal to 1951 kilonewton. So, Q safe, this is Q ultimate divided by the factor of safety, which you can take 2.5 to 3. So, that is equal to 780. So, the allowable or safe load carrying capacity of this particular single pile is 780 kilonewton. Similarly, this way you can do it for the layered soil also, and you can do it for the dry soil also, but here we have taken the homogeneous soil with water table. So, next part I will discuss that how IS code recommends to determine the ultimate load carrying capacity of the pile. So, in sand. Okay. So, all the equation that we have discussed is for the granular soil. Here also IS code also recommend this equation, which is similar to the previous equation, but the only difference is that in case of previous equation we have neglected the third part for pile load carrying capacity calculation, because the third part contribution is less compared to the second part, and first part is already 0 because C is equal to 0. But IS code also recommends to take that third part. So, this is the equation This is the second part that we are right now we are using, that is sigma dash into NQ, which is similar to that PD into NQ, and then this is the third part, which is half d gamma n gamma, which you have to use if you use the IS code recommendation. And then other is the summation of the friction resistance. So, this part is the tip resistance and this part is the summation of friction resistance offering by different layers. This is friction, which is same as the equation that we have discussed, that in the K PD is the your effective overburden pressure. So, PD is the effective overburden pressure at tip and PDI is the effective overburden pressure at different layer. Okay. So, and Ki is the earth pressure coefficient at different layer. So, here also it is recommended that for the driven pile for loose to dense sand, this 30 to 40, the previous recommendation which is same as the IS recommendation, that K value varies from 1 to 2, and for the boat pile for 30 to 40 K value varies from 1 to 1.5. Okay. So, here K value is given for boat pile and the driven pile separately, but previous cases we have to determine the values for the driven pile, then by the given recommendation you have to use it for the boat pile. So, this is the equation for the as per IS code, and then here also IS code also given recommendation for the critical depth. So, that critical depth is again 50 to 20, that means if it is less than equal to 30 degree phi value, then the critical depth is 15 d, and if it is greater than equal to 40 degree, then the critical depth or critical length of the pile is 20 d. If the phi value is in between that means loose to dense, then you have to take the critical depth accordingly. So, and here the delta value is recommended to take as equal to phi. Okay. And again the PDI is the effective overburden pressure, which is the average effective overburden pressure at a particular layer, and the same way it has to be calculated as I have discussed. Now, there is a two bearing capacity factor, one is N gamma and N Q. So, N gamma you have to use the N gamma that we are using for the shallow foundation, and this is the value of N gamma for different phi value, and the NQ we will get from this chart, where this is the NQ versus friction angle, and the first chart or the left hand side chart is for the driven pile and right hand chart is for the boat pile. So, from here we can get the NQ corresponding to different friction angle value. Now, next part is the pile ultimate load carrying capacity of pile in the clay. So, here also we have a tip resistance and the friction resistance. So, tip resistance we will get only CNC and the area of the base area of the pile, and friction resistance is the adhesion factor into the undrained cohesion into the area outside area of the pile. So, this is the expression is given here. NC is generally taken as 9, although different researchers has proposed different NC value in case of pile also, but generally it is taken as 9. So, here also we will take this value as 9, and Cu is the undrained cohesion at the base of the pile, AB is the area of the pile base, and alpha is the adhesion factor, and Cu is the undrained cohesion along the or average undrained cohesion along the length of the pile, and As is the outside area of the pile. So, that means for this particular case pile must go at least 5 d inside a bearing strata, because it is going through a clay layers, but if I use the tip resistance, then the pile has to be inserted into the inside a bearing strata up to 5 d. So, again the how we will calculate the adhesion factor, the dash value is given here. So, that means for soft to very soft, adhesion factor for board pile is 0.7, driven pile is 1, to steep to hard soil where the board pile is 0.9 and for driven pile also, for board pile the value of alpha is 0.3, for driven pile also it is 0.3. And when we can say this pile soil is soft soil, very soft soil, medium steep, very steep, hard. So, as per the undrained cohesion value that can be classified. So, that table is also given. So, for if you have the undrained cohesion value, so based on that you can understand whether soil is soft or very soft or steep, then based on that you will decide what alpha value you will choose. Similarly, IS code also given the same type of expression, where this is CNC and then the friction resistance, which is summation of the friction resistance the pile is getting for different layer, and here the adhesion factor chart is given for different undrained cohesion value. So, if undrained cohesion value is less than 40 kilonewton per meter square, then you take the alpha value is equal to 1. Alpha is the adhesion factor. So, you can say if it is less than 40 kilonewton per meter square, then you take 1, otherwise you can take the adhesion factor according to the undrained cohesion value. Next one I will discuss about the pile load test, because previous case was the how to calculate the tip resistance and the friction resistance by theoretically. Now, here I will get the load carrying capacity and the settlement of the pile by pile load test. So, it is the only direct method for determining the allowable load on piles. It is a in situ test and most reliable one also, because here these things we will get from the field directly. So, it is very useful for cohesionless soil. However, for cohesive soil you have to use this pile load test data very with caution, because the pile driving disturbance, poor water pressure development and inadequate time allowed for the consolidation. So, these are the factors, because we are this pile load test is a short term test, but that means we are not allowing the consolidation or the full consolidation. So, these things, because of these things we have to use this pile load test data with caution for clay. So, pile load test can be done under 3 different loading conditions: vertical load or compression, then the lateral load, then the tension load also. It is not only the pile load test can be done under compression, it can be done under tension, under lateral load also. Then pile load test, when you are doing, we have to do it for the 2 types of pile. One is called initial test, or those tests are carried out on the test pile. So, that means these piles are test pile, where the initial tests are carried out. So, what are the test pile? Test pile are used to estimate the allowable load and to predict the settlement at working load. It does not carry the load coming from the superstructure. So, that means test piles are used for testing purpose only. So, these piles will not be used for real load carrying purpose. Okay. So, then no superstructure load will come on the test pile. So, these test piles are used for testing purpose, then there is no use of these piles. So, I mean where no information is specific information is given about the subsoil strata, or there is no past experience for a project involving more than 200 piles, there should be minimum 2 initial tests. So, that means how much load we can apply on a test pile? So, minimum load on a test pile is twice the shape load, or the load at which total settlement attain a value of 10% of pile diameter for single pile and 40 millimeter in group pile. So, that means we have to first calculate theoretically what would be the safe load for a particular pile, then you have to apply the load during the pile load test twice of the safe load, or if before that the settlement of the pile attains a value of 10% of the diameter for single pile or 40% 40 millimeter for group pile, then we will stop. Either we will go up to the 2 times of the safe load, or we will go the 40 millimeter settlement for group pile or 10% of diameter settlement for single pile. Okay. So, now next one is the routine pile, which is conducted on working pile. So, working pile means this pile will be used in future also, that means the superstructure load will come on this pile. So, after the testing also this pile will be used for the real load carrying purpose. So, these tests are carried out to check on working pile to assess the displacement corresponding to the working load. The minimum number of routine tests should be 0.5% of the pile used. So, it can go to up to 2% depending on the nature of the soil strata and the importance of the structure. So, how much load we can apply on a working pile? So, we can apply maximum 1.5 times of the safe load or the load at which the settlement attains 12 millimeter for single pile and 40 millimeter for group pile, whichever is earlier. So, in the initial test or the test pile, then we have to apply at least 2 times of the safe load, but here we have to apply maximum 1.5 times of the safe load. We cannot go beyond 1.5 times of the safe load, because these piles we have to use after the test, or the total settlement at which or total load at which the settlement attains a value of 12 millimeter per single pile or 40 millimeter per group pile. So, whichever is earlier. Now, pile load test can be 2 types. One is the continuous loading and is the cyclic loading. So, continuous loading means the continuous increment of load is applied on the pile head, and cyclic loading. So, loading is raised up to a particular level, then drop to 0, again increase to a higher level and reduce to 0, and so on. So, the purpose of the cyclic loading, that by cyclic pile load test we can determine the steep resistance and the friction resistance separately by pile load test. So, the continuous loading or the pile load test procedure is it is carried out by applying the load on a RCC pile cap. Load is applied in an increment of 20% of safe load, because first you have to calculate the safe load, then first increment we will apply the 20% of the safe load, then the 40% of the safe load, then 60, 80, 100 to 2 times or 1.5 times or the up to the specific settlement. Then settlements are recorded at 3 dial gauges and average values are used as a settlement of a pile corresponding to a particular load. Then each stage, each loading stage or each increment is kept on the pile till the movement of the pile top is not more than 0.1 millimeter per hour. Now, once you get the or once you complete the pile load test, you will get a load versus settlement plot. So, this is the load or the stress and this is the settlement. Okay. So, we will get particular load versus settlement plot. So, once we get this load versus settlement plot, then we can apply this recommendation which is given by the IS code. So, by giving this recommendation, we can determine what would be the allowable load on a single pile. So, what is that recommendation? The 2/3 of final load at which total settlement attain a value of 12 millimeter. For example, suppose this is a 12 millimeter value. So, we will calculate corresponding to this load Q 1. So, we will take 2/3 of Q 1, okay, corresponding to 12 millimeter. If other permissible value is specified, then you have to go for that value. If nothing is specified, then we will consider 12 millimeter is a permissible settlement for single pile. If any other value is specified, then you have to go up to that settlement. Okay. But here nothing is specified, so you are taking 12 millimeter. So, it is 12 millimeter corresponding Q 1, this is 2/3 of Q 1, we are taking them Q 1 2/3 of that. Next one, 50% of pile diameter. For example, if diameter of the pile is say your 500 millimeter. So, 10% of that will be the 50 millimeter So, we will go to 50 millimeter settlement for this particular case, if the diameter of the pile is 500 millimeter, then this is the corresponding load. So, this is the Q2. So, we will get 50% of that Q2. So, we will get half of Q2. So, the Q allowable will be minimum of 2/3 of Q1 and half Q2. Okay. So, this way we can determine the allowable load carrying capacity of the pile from pile load test data. So, this 10% is for uniform diameter pile and 7.5% of the bulk diameter in case of under rim pile. Under rim pile means where we provide the bulk. So, we will discuss the under rim pile load carrying capacity when you discuss the pile in expansive soil. So, that time I will discuss that. Okay. So, now for the group pile, the criteria is that final load at which total settlement attains a value of 25 millimeter. If nothing is specified, then the 25 millimeter is the permissible settlement for the group pile, or 2/3 of the final load at which total settlement attains a value of 40 millimeter. That means, we will take full value corresponding to 25 millimeter full load and 2/3 of the load corresponding to settlement of 40 millimeter, and minimum of these two will give you the allowable load carrying capacity of the group pile. Okay. So, initial recommendations were or criteria were for the single pile, and this is for the group pile. So, now I will determine the load carrying capacity of the pile based on this plate load test. So, following data was obtained for a vertical pile load test, that is pile load test of 30 millimeter diameter. Determine the allowable or safe load as per IS 2911 part 4 1979. So, as per these IS code means the recommendations that I have discussed previously. So, this is the load versus settlement, and I have drawn this curve. So, this is settlement and this is load. Now, first recommendation was 2/3 corresponding to 12 millimeter settlement. So, 12 millimeter will be here around. Okay. And the value will be 230 kilonewton. So, first criteria will be 2/3 of 230. So, that is 153 kilonewton. Now, second criteria 10% of diameter, because it is a uniform pile. So, 10% of diameter means diameter is 30 millimeter, 10% of 30 millimeter, that is equal to 10% of 300 millimeter. So, this is 30 millimeter. So, 30 millimeter is here. So, corresponding value is 400. This is 400, this is 410, and that load we have to take 50%. So, half of 410. So, this is 205. So, minimum of this 2 is 153. So, Q allowable is 153 kilonewton. So, this way we can determine what would be the Q allowable or safe load carrying capacity of the pile based on the pile load test. So, the next part that I will discuss the topic that I will discuss in detail, that how analytically we can estimate the load settlement behavior of the piles. So, previous problem we can see this load settlement behavior of the curve that is generated, it is based on the pile load test. Okay. So, in the next class, I will discuss that how I can generate this type of load settlement curve or similar to this type of load settlement curve analytically by using the equations, not by the plate load test, because we have the soil properties and based on those properties we will try to develop a particular load settlement curve for a particular soil, for load settlement curve for pile for a particular soil. So, that I will discuss in the next class, and then I will discuss basically two methods, and then I will discuss the I will also solve one numerical problem to show you how we can determine the ultimate load by using that theoretical approach, where we will get the load settlement curve as well as the settlement and the ultimate load, or settlement means settlement at ultimate load point, or we can get a simple load settlement curve and ultimate load and the settlement by theoretical approach. Thank you.